All right, dude, we are live. What's up, guys? This is Dem Keys, and I guess I could be wrong, but I think I haven't streamed for like 10 days. Um, let me see if I can get an accurate date on my last stream. Give me a second. Let's go to my channel. Open this up. Open this up. You guys can't see any of this because like I'm doing it on. Yeah, okay. So it was 11 days ago. It's a good thing that I date my streams like in the title. I thought the title might have been wrong, but I guess it wasn't. Dude, it's been crazy, dude. I've been trying to stream, but like things just didn't work out. On the bright side, I have been doing a whole lot of research, and well, I'm still carrying on with my research. I actually got kind of distracted. I went into a little like hyper focus thing for the past couple of days, and I was like diving deep into actually for the past week, and I was diving deep into GPU architecture for good reason, because I've been doing research on CUDA. And dude, it is amazing to me that like we are actually able to do CUDA programming through Python. Not necessarily with Python, but through a library, or let's say a module called PyCUDA. You have the ability to, just a minute. Okay, yeah, you have the ability to load CUDA code into your Python program, or you can basically execute CUDA code through your Python script instead of having to write C++ code for it. At some point in time, I'll be diving into that as well, because it's going to help me do a whole lot of GPU computing, as in general purpose GPU computing. That, and I've been diving into compute shaders as well, so I can do GPU computing in Unity. I've also been doing a fair bit of research on neural networks. Dude, holy shit, neural networks are they're really interesting. Holy shit. Like even the most basic neural network, it's super interesting to me how the whole system works. How you're able to take a problem, present it in terms of numbers, and then feed that into the neural network. The network has to be trained. You can't just construct a network and expect it to work. It has to be trained, and the training process is also pretty interesting. Like a lot of the stuff, I'm going to be going into it myself before I decide to use any of the libraries, which I do plan on using the libraries as well. Dude, I should have started this stream and like in just chatting or something, because like I've been talking for like close to 4 minutes now. Anyways, we should get into what we are planning to do today. So today's stream is mainly only going to be Python. I'm learning how to do, well, again, learning how to do networking in Python. I touched the networking topic in Python ages ago, like a long time back, and I did a bit of networking stuff. I set up a simple, I think it was a simple HTTP server. I didn't really touch sockets at that point, but now I'm touching sockets. Like I need to, saying I'm touching sockets, it sounds kind of dangerous. I'm talking about web sockets, like sockets in the operating system. So I'm learning how to do programming with WebSockets in Python. I know how to do it in C#, and now I want to learn how to do it in Python as well, because one of the projects that I'm working on, which is my VTubing application, one of the components of it is going to need to be able to communicate with a Python script. So that's why I'm spending time learning about this. There's also going to be a lot of other uses for me. Man, there's once, I don't know, it's just, there's so many things I want to build for my stream, but I feel like I spend so much time learning how to build things, which in a way it's a good thing, because like for me, the joy of all of this, it comes from actually creating the things rather than using the things. So yeah. Anyways, let's jump into this. So I'm looking at the socket modules documentation page. I don't know how well this is going to work with Jupyter. I have a Jupyter notebook running here. It's just a lot easier. It's a lot more convenient to run code in a Jupyter notebook, because like I can do something like this and then just hit Control Enter. Oh, give it a second. Let me. This is the initial setup that needs to be done. I need to let Jupyter do its own initialization, and then I need to select a Python environment to run in, which is my current environment that I have activated. Give it a couple seconds. It'll be done soon. In the meantime, I can carry on reading. So this module provides access to the BSD socket interface. It is available on all modern Unix systems, Windows, Mac OS, and probably additional platforms. Alright, cool. This module does not work or is not available on WebAssembly. Alright, fine, that's cool. The Python interface is a straightforward... Okay, give me a sec. Okay, yeah, this is done. So this is what I was trying to show you. All I have to do is type the code and hit Control Enter, and it runs. So, whereas if I had a Python script, I would need to give me a second. I'm just adjusting my mic. Okay, if it was a Python script, I would need to do something like this: open up the terminal and then type Python and then whatever my script name is. And having to do that each time is kind of inconvenient. So just being able to do something like this, it's super convenient. But notebooks are not just made for this purpose. Notebooks also provide you with a bunch of other features. So for example, so this right here is called a cell. You can create additional cells. In this case, you can create two types of cells: a code cell or a markdown cell. A markdown cell is basically when you want to add only text, not any code that's gonna be executed. And because you have this system of cells, you can kind of break up your code into various chunks. And this is especially useful if you have certain code that you don't want to be running all the time. You only want to run it the first time that you open, for example, the first time you open this notebook, you only want to run that code once. So it initializes a bunch of the variables. And then in future cells, in the, you know, succeeding, in the further cells, I guess succeeding cells would be accurate. But anyways, in the next few cells that you make, you'll just be able to run your code and access those variables that you initialize at the beginning. This saves a lot of time, especially if your initialization, for example, involves something time consuming, like reading a file or parsing a massive data set. I recently had a project that I worked on. Give me a second. Yeah, I recently had a project that I worked on that required me to do that. And it was actually an exciting project for me to work on as well. I'd been given a couple of files. Unfortunately, I can't really show that here because I don't have it on this system. I did the coding on another system. It was to help someone out, so I was using their laptop. So I'd been given multiple files, and I had to extract specific data from those files. They were Excel sheets. I had to extract specific data from those files, and I had to do some processing on it. And basically, the whole idea, the end result was supposed to be plotting it onto a graph. But before doing that, I had to prepare the data set, because I had data. I didn't have the data set. I had to prepare the data set myself by extracting the data from those multiple files. There were like more than 100 files. I think it was 144 files, if I remember right. And I had to figure out ways to get that specific data that I wanted. And I did that. But that's just one example, because like that one operation, oh yeah, I was explaining what exactly I did there. So I extracted the data first. I extracted data from those files, and then I had to do some pre-processing on it, make it a little more standardized. There were months in there as well, so I had to make those months standard, in the sense, in some of the files, for example, you take the month April. Some of the files mentioned April as April, which is the full spelling. Some of the files mentioned April as APR. And you had a similar situation going on for September, October. Like, some of them were shortened, some of them were the full name. So plotting, it becomes a little difficult when you don't have standard data. Like, the data doesn't all match a specific pattern. So I had to write a little bit of code to sort of pre-process that data and fix various issues. Fortunately, it wasn't too hard to do that. In some cases, I needed to use a bit of math here and there. But yeah, that was a good experience, because not only did I learn how to I knew how to plot data, and so this was a good practice session for me. But this also gave me some experience of pre-processing data, because I was given the data. I wasn't given a data set. So in order to plot it, I would have to prepare the data set. Before preparing the data set, the data has to be standardized. Otherwise, plotting it is going to give you it's going to give you unintended results, let's say. Dude, I really should have been in just chatting for this, because I've just been talking so far. Anyways, let's get back into networking. Okay, the Python interface is a straight... Give me a second. Let me make sure the music is still going. Yeah, okay. The Python interface is a straightforward translation of the Unix system call and library interface for sockets to Python's object-oriented style. The socket function returns a socket object, whose methods implement the various socket system calls. Okay, let's stick with this. Let's say S1 equals socket I don't want to have to type socket each time, so let's just do sock dot socket. And this is a constructor, right? Or, well, I mean, this is a class instance, but like, what does the constructor take? It takes a family, an address family, a socket kind, and I'm not sure what proto is. I can look at that over here. Okay, let's carry on. Returns a socket object whose methods implement the various socket system calls. Okay, so fortunately, I already have a good deal of knowledge when it comes to sockets. I've done a fair bit of research on this. I even had to go all the way down to like the operating system level to get an understanding of how specifically two types of sockets work, the TCP socket and UDP socket. There's other types of communication that I would like to learn to set up in the future, because sockets, they support more than just, I mean, I can't speak for Python, but like sockets generally, they support, if you see in C#, for example, sockets give you multiple options for like different types of communication. I can't remember off the top of my head, but there's a bunch of different options there. Someday I would like to go into that, because I feel like it would give me a way to like visualize data in the various layers, in the various what is it called? Because I remember the OSI model, but there was another one called, I think it was just called the IP model. TCP IP model? No, just the IP model. Basically, the OSI model is, it's a conceptual model that helps you understand how data goes. How do I explain this? It gives you an idea of what happens to your data from when it goes from your computer to another computer. So like from the time where you, for example, type into your browser google.com, what exactly happens there? You have the application, you have your operating system, you have whatever drivers are running, you have the kernel, you have your hardware. From your hardware, it might go to the router. I don't think it includes the router. I don't think the OSI model probably doesn't include the router. I don't know if the IP model includes it. I'm gonna have to look into that. But yeah, even going all the way down to the hardware layer, basically all of these different levels that I just mentioned, they are described using these multiple layers. The OSI model has what I think 7 layers. You have a bunch of different. You have names for them. Hey, you know what? Let me just Google it, since I am going on a tangent about this. Let me just Google OSI model. Okay, here it is. So okay, so the various layers are the application layer, the presentation layer, the session layer, the transport layer, network layer, data link layer. I think data link layer is where it goes into like the hardware stuff. I think even the network layer might be considered hardware. I'm not sure. Transport layer is still software, but like very low level stuff. And then you have the physical layer, which is definitely your hardware. Why was I explaining this? Oh yeah, so I feel like looking at all the different, I feel like exploring the different types of sockets that I'm able to create is gonna help me visualize multiple layers here. I don't know to what extent. I'm probably not gonna get close to the physical layer using just sockets, because sockets are more of an operating system level thing. Oh, actually, I mean, if that's the case, then I'm probably not going to be able to look at the network layer either. Okay, enough with this. Someday I want to explore more of those. I want to explore more of the layers to get a better understanding of how these things, how the data is transformed as it goes through each of these layers. Because it's kind of interesting, because like it goes from top to bottom when it's leaving your system, but then going into the other system, it goes from bottom to top, because that data then has to go through those exact same layers that it went through previously But now, instead of being deconstructed into, something that the hardware can understand, it's now being reconstructed back up into something that the human can understand. Okay, give me a second. The system is being a little fussy. All right, cool. So, where was I? Parameter types are somewhat higher level than in the C interface, as with read and write operations on Python files. Buffer allocation on receive operations is automatic. Buffer allocation on receive operations is automatic, and buffer length is implicit on send operations. That's interesting. Cool. Yeah, I had a doubt that like doing this in Python is going to be a lot more convenient than doing it in C sharp. It's not that it's horribly inconvenient to do it in C sharp. It's just that the great thing about a language like Python is that a lot of the stuff that you do, a lot of the work tends to be done for you already. So you don't have to write a whole bunch of extra code for validations and catching exceptions and all of that stuff. It's great to write all of that stuff for like an end user application, but if you're trying to get some work done real quick, and if it's just a project for yourself where you don't really care if the script crashes or something, you don't need to write all of that code. And like that's just when we're talking about exceptions. There's a lot of situations where I've found myself writing a lot of boilerplate code that didn't necessarily need to be written. It could have just been, so various values could have been initialized like automatically, and then I could have been given the option to change those values if I chose to do so. But like some people are just looking for default behavior, because the default behavior, it works perfectly fine for them. It gets the whatever goal they're trying to accomplish, the default behavior, it accomplishes the goal for them. So like that's one of the things I like with Python. There isn't like a whole lot of setup going on. It lets you get things done real quick. Even something like reading a file, even something like writing to a file, it is relatively quick, because like a lot of boilerplate code it's already written for you, and a lot of stuff gets automatically handled. Whereas if you look at something like C sharp, for example, or even worse, something like C++, there's going to be a whole lot of coding you're going to be doing there. Okay, back to what we were doing. So, socket families. Okay, let's see what socket families. Oh, okay. Hopefully we are good. Yeah, for some reason my thing just crashed. My internet just shut down. It is what it is. This stuff happens. Fortunately, this time I managed to get it back up before the disconnect protection ran out, and I'm glad that I set up this disconnect protection. Shout out to Twitch for that. Also, speaking of shouting out Twitch, something I want to set up, something I'm excited to set up, is the new alerts feature. Twitch actually released the alerts feature recently, so now alerts are natively supported in Twitch. you as a streamer have a separate alerts page where you can set up alerts for stuff like follows. I'm just looking at the page right now. You can set up alerts for follows, subscriptions, gifted subscriptions, cheers, raids, charity stuff, hype trains, and for your goals. I'm assuming they're going to be adding more such variants in the future. Yeah. I'm assuming they're going to be adding more categories in the future, hopefully. I would like to see one for channel point redeems, because that way people can set it up so sounds can be played automatically. Right now, you would probably have to do it through some other service. Whereas here, given how customizable this system is, it allows you to set things up pretty much the same way you would do in Stream Elements or in Streamlabs or any other similar platform. I don't know how loud this is going to come through. I hope it doesn't come through too loud, but I'm just gonna play the test. I've kept the volume fairly low, so hopefully it doesn't come through too loud, but like I'm just gonna send one of the alerts. Okay, yeah, fortunately it wasn't too loud. Actually, I haven't set this up, I haven't set it up on this. Oh shit, okay. You know what? It's a good thing I'm in studio mode, so I can just do it now. Where are the properties? Let me just grab the source. Okay. Let's bring it over here. Let's add a browser source. Oh, so yeah, this is also this is done through a browser source, so there isn't like a whole lot of change in the setup that you have to do. Pretty much like you were doing it with your previous setup, you would do it now with this setup instead. Let's just, yeah, we'll just call it browser 5. That's fine. Let's do that. Okay, and now let me center this. Where's the center option? Center to screen. There it is. Let me hit test. Ah, there it is. So you guys can probably hear it. You just can't see it yet. So I'm gonna now transition. And hopefully now it shows up. Yep, there it is. Cool. And it should be popping up on screen as well. Yeah, cool. Yeah, there's a bit of a delay. Not for you guys, but like for when I saw it on this other screen that I'm running things on. So, yeah, this is a test alert. What does that say again? I didn't actually pay attention to what that says. Hold on. Let's preview it here. I can't see the text. Hold on. Okay, let me send that again. And let me full screen my own thing. Oh, it says I just followed. Okay, cool. But yeah, this is just one example. You can set up like multiple variants of this. So I'm assuming you can have like different types of follow alerts. You can also specify like a because you have like variants, you can specify a priority, or you have a list. You can choose the order to tell it that, yeah, okay, give this variant higher priority, give the other one lower priority, and so on. So whichever the top one is, you also have conditions. So whichever one's condition is met and it's like at the topmost one that's whose condition is met, that variant is going to be used. There's so much more. Like I want to explore as much of this as I can. I also want to go into the CSS part of it because it lets you, I'm assuming it lets you enter custom CSS. So that'll give me an option to or that'll give me an opportunity to practice some CSS, which I quite frankly haven't touched in years. I'm not even kidding about that. Like I haven't touched web development in years. I was going to be getting into it later on again, not web development specifically, but CSS. Um, Not exactly CSS though. I was going to be getting into it because like okay, Unity has a new framework that you can use to make UI. It's called UI Toolkit, and it is very different from the previous framework. And the great thing is now you can use this same framework to make UI for both in-editor tools and in-game UI. So you have this one central kind of thing. Okay, there's an ad playing. So I'm going to stop talking for 30 seconds and probably hydrate. Okay, welcome back. So, um, yeah, UI Toolkit. UI Toolkit is pretty amazing. Like the bit of research that I've done on it, I didn't get a chance to go too deep into it, and I would definitely like to go deep into it. Because that's going to be the future of creating UI in Unity. It's great because creating UI has become a lot more not complicated but sophisticated. Because you have, wait, that dude streams? What? I didn't know that. All right, okay. So, um, shit, I forgot. What was I saying? Yeah. Okay. So you now have a proper designer that you can use, like an a designer window to create your UI and to customize the UI. You can also enter custom US. Oh, okay, yeah. So that's where the CSS thing comes in. It's called USS in Unity. It's a CSS based language. Like it I believe it takes a lot of inspiration from CSS, or it's sort of there, like they've built their language on top of CSS. I don't know which one it is, but apparently it's very similar to CSS. So if you have CSS knowledge, you'll be able to you'll be able to get into it. So there's a couple of different like moving parts to the UI toolkit that I need to learn about, that I definitely want to learn about, because like where we are going in terms of even Unity stuff, I feel like teaching people how to build editor tools is going to be very beneficial for them. Because I remember back in the day, I made a couple of editor tools. You can find them on my GitHub. Some of them were like widely. I was about to say widely accepted, but what I meant to say, they were widely appreciated. I made a category tool, a category kind of thing. Um, which back then, and I'm talking about a couple of years ago. Shit, what was it? Maybe 5 years ago. Unity didn't have a category kind of thing. So like in the hierarchy, you couldn't specify, you couldn't group objects together in a specific category. You could make them children of a parent game object, but like that wasn't always the most convenient thing. Let's just put it that way, because it can have some side effects. It has a it kind of changes the way you have to do things, because you now have these objects that are not, they're not part of the scene. They are children of this other game object. So that was the way people were grouping or categorizing. Another way people had found to categorize was to just create game objects with a bunch of hyphens in the name, and they would use that instead. So I looked at that and I kind of got an idea that, okay, maybe if that's how people are doing it right now, maybe I can make it look a little better. So I spent an entire day, I think, working on a tool that lets you create categories. Um, it was good for what I did back then. Like considering my Unity knowledge back then, it was great, dude. I keep on going on these tangents. I should really be in just chatting. Like we have, it's been what, um, it's been now close to 40 minutes of the stream, and I've mainly been talking and reading this stuff. Okay, let's get back to, I don't know where I stopped what I was just saying. Did I finish my sentence? I got distracted. I'm watching someone else's stream right now. Um, that's just how I study. Okay, so we were reading about the address format for socket addresses in Python. So, oh yeah, I was gonna look at, how do I get it? Sock.af family, AF Unix? No, what is it? AF. Oh, it's all of these. Okay. So it has to be inet, not inet 6. That's the address family. I remember that from C sharp. So it's a internetwork family. And then the socket type. Um, so this is address family, socket kind. Oh, there it is. Sock underscore dgram raw. Oh yeah, okay. So dgram is datagram. I'm trying to create a UDP socket, so I need to go for datagram. Raw is one that I want to look into. Stream is for TCP. I want to look into raw at some point. I want to look into, I think this is sequential packet. I'm not sure. RDM, I'm not sure what that is. But yeah, I want to look into all of these at some point. What is protocol? Protocol. Okay. What's the well, yeah, okay, it's UDP, right? Why do I have to? Okay, let's just. Well, yeah, okay. I see why I have to, but yeah, fine. How do I specify? Let's type UDP. SOL dot UDP. Is that what I'm supposed to look into? What about TCP? SOL TCP. Okay, yeah. So I'm supposed to. I think it's SOL UDP. Uh, what is file number? I'm not sure what file number is supposed to be. I think it'll resolve itself if I don't specify a file number. Uh, Oh, wait a minute. This is interesting. I didn't know that it supported. Hold on. So we have, apparently there's a Bluetooth, there's an AF Bluetooth. What are the different types here? So we have a couple of different, we have Apple Talk, we have DeckNet. Of course, we have Bluetooth as well. I want to look into Bluetooth, dude. That's kind of interesting. Yeah, I'm actually really interested in that. Okay. Anyways, so what I'm looking for is, oh, this is cool. AF packet is a low-level interface directly to network devices. The packets are represented by, oh, dude, yeah, I think I'm gonna be able to get like a decent amount of low-level info because like I was talking about like OSI, the OSI model earlier. Okay, okay. Going down to what I was looking for, which was iNet. Okay, where is iNet? A pair is used for iNet. How am I supposed to initialize this? Like, where exactly am I supposed to mention the address format required by a particular socket object is automatically selected based on the address family specified when the socket object is created. Socket addresses are represented as follows, but like it didn't ask me for an address, it asked me for an address family. Is that when I try to, what are the methods provided here? So we have the typical methods, accept, bind, close, connect. Is it when I try to connect? Is that when it's going to ask? Yeah, there's the address. Okay. What does it say here? A pair, host, port. Oh, okay, cool, cool. Is used the for the INET address family, where the host is a string representing either a host name in internet domain notation, like so and so, or an IPv4 address, like so and so, and of course the port as well. IPv4 addresses, for IPv4 addresses, two special forms are accepted. Instead of a host address, an empty single quotation represents in address any, which is used to bind all interfaces. What about a loopback? Does it have? Actually, okay, I don't think I'm going to be using loopback anyways. But I mean, there should be an option for loopback. I'm pretty sure there's probably going to be an option for loopback. Okay, um, what is it? Host port equals. So there's our tuple. Um, wait, I don't think I need to specify. I don't think I need to mention the. Okay, okay. Yeah, sorry about that. I got distracted. Okay, so this is a tuple. How am I meant to pass this? I'm meant to pass this as an address. Okay, let's test this out. Host port equals let's say 1 and 2. Okay. What would host be classified as? And how would I don't think this could be stored in a variable unless like, how do I name the tuple? Well, okay, I can only give one name for the tuple. I can't necessarily name the, okay, I got distracted again. What was I was saying something. Yeah. So I was talking about naming the tuple, but like if I'm going to name the tuple, it has to be one name, right? So for example, A equals 1, 2, and then the type of A would be a tuple. Okay, cool. Okay, do I need to address family, address? Do I need to create the thing like this? Like, is there a constructor for this? Wait, if it starts with a, wait, no, this is an iterable. That's an object. That's an object. Okay, okay. Okay, I should probably look at examples here. Dude, for the past like, hold on, dude. I'm getting so distracted here. Um, okay. So where are the examples here? So this does, okay, let's try this. So s1 dot connect, wait, so let's say addr equals 192.168. Let's just do a generic. You know what? Yeah, let's do a, dude, I need to find out what the loop, how to get loop back. Or maybe it's like a number or some shit. Hold on. Python socket loopback. Okay, loopback address. How do I get the loopback address? Oh, will 127.0.0.1 actually work? Okay, well, let's try it out. So that's our address. And this is our port. I think that's supposed to be an integer. So let's do 9,000. Actually, no, let's do 9,010. Okay, s1 dot connect. What is connect x? I need to look into that. So let's see if this runs. What does this return? This returns none, right? Okay. Okay. So I'm guessing it worked. That's how simple it is. Just connect. Well, okay, to be fair, I mean, I haven't set up a proper server, but okay, so we have connect. You know what? Maybe I can set up a server on real quick. I'm not going to do anything on this system, but on another system that I have running, I'm going to set up the server. I think I have, what am I running here? Python? No, shit, I'm running some other project. Um, let's open up a new window. I guess I'll just talk as I'm doing this. So I'll like describe what I'm doing. And this keyboard that I'm using for this other system is kind of rough, so you might also be able to hear the keyboard ASMR. I think I had a networking project set up here a while back. I had one set up for C Sharp. I think I had one set up for Python as well. I have like netproj Python. I think that's the others are mainly in C. At some point I tried to do this in C, I guess. I don't know. Did I try to do this in C? I don't even remember trying to do it in C. Though, I mean, yeah, that was probably a while back, so yeah. Okay, let's open this. Let's why is wait, what did this just open? This just opened a C Sharp project. Did I just try to open a C Sharp project here? I thought it was in Python. What is the location of this file or this project? Give me a second. I'm just gonna keep talking while I'm doing this. Okay, so for some reason, this project is located in the Python folder. So what I'm gonna do is delete this whole thing and also close everything here. And then I'm gonna initialize a new environment. I'm gonna create a new Python environment and then create, yeah, I'm gonna have to install Jupyter again. Though that shouldn't take too long on this system, hopefully. Just give me a second while this thing gets done. And they are all gone. Great. Cool. So now that there's nothing here, we have the terminal open. Nice. Great. So what do I need? I need Python mvenv env. Okay, so that created our environment. Great. Now source env, what was it? Bin activate. All right. Pip install Jupyter. Let that install. That might need to download a couple of things. Hopefully it doesn't affect the internet speed. Oh, good. Okay, it's collecting a bunch of the cached stuff. So that's good. Okay. Let this get done. Once this is done, so what am I trying to do here? Okay, so if I'm making a UDP server, I need the server to Does a UDP socket need, does a UDP server socket need to bind? I don't think it does. It needs to listen and then accept. Is there a listen? Yeah, there's a listen. Is listen a blocking operation in Python? I'm not sure. Generally, like in C Sharp, it would be a blocking operation, which is why you would need to use one of the async methods. So you could do it on a different thread and then return the result back. Um, Python socket listen. Okay, let's open that up. Uh, oh, okay, here's a list of the constants. Cool, cool. So we have the address families, we have the socket types, and we also have the protocols, I'm assuming. Okay, creating sockets. Oh, wait, okay, so socket, what I called earlier was actually a function. I thought I was initializing the class. Okay, cool. Creates a new socket using the given address family, socket type, and protocol number. The address family, okay, yeah, all that is fine. Great. If file number is specified, the values of family, type, and proto are auto-detected from the specified file descriptor. Auto-detection can be overruled by calling the function with explicit family type or proto arguments. This only affects how Python represents, example, the return value of get peer name, but not the get peer name. What is that? Returns a remote address to which the socket is connected. That is good to know. That is definitely good to know. This is useful to find out the port number of a remote IPv4 or 6 socket, for instance. Great. Cool. Cool. Okay. Okay. The newly created socket is non-inheritable. Okay. Great. Oh yeah, I didn't think about whether I need to wait, yeah, dude, I was supposed to look at socket.listen. Wait, there's a create server. It's a convenience function which creates a TCP socket bound to address so and so and returns the socket object. Okay, so this is for TCP. What if I want to create a UDP? So you know what? I have the socket server module that I want to dive into next because this is going to be for like individual like communication, but for the final thing, for like my actual project, I'm not going to be using like just bare bones socket stuff. I'm going to be using a socket server, which is already made. So I don't have to handle a lot of the other stuff. I don't need to write a lot of the boilerplate code. Okay, okay, okay. All right, great, cool. Um, okay, okay. Um, why am I not able to find listen? Okay, so we are in H, uh, HIJKL. Okay, Man, okay, these names are not, they're like in a weird order. I don't, hold on, let me just do control F. Socket.lesson. Now where the fuck is socket.lesson? Why was I not able to see it? Oh, okay. What is this method? Returns a file object associated with a socket. The exact return type depends on the arguments given to make file. That's interesting. The socket must be in blocking mode. It can have a timeout, but the file object's internal buffer may end up in an inconsistent state if a timeout occurs. Closing the file object returned by makefile won't close the original socket unless all other objects have been closed and socket.close has been called on the object. Now that has me wondering, like I didn't close, um, well, it's a UDP server, it's a UDP socket and I haven't specified. Oh, there's also the fact that there's nothing listening. I didn't, I didn't consider that because like I'm trying to connect. Wait, I'm trying to connect. Why is it not giving me an error? Let's look for socket dot connect. Connect to a remote socket at address so and so. If the connection is interrupted by a signal, the method waits until the connection completes or raises a timeout error. Uh, if the signal handler doesn't raise an exception and the socket is blocking or has a timeout. For non-blocking sockets, this method raises an interrupt error exception if the connection is interrupted by a signal. This method now waits until the connection completes instead of raising so and so. Okay. So it's just gonna wait. Oh, maybe I should be using connect underscore ex. Let's do res equals this, and then let's print out res. Okay. Um, the error indicator is 0 if the operation succeeded. Otherwise, the value of the error number variable. Otherwise, the value of the error number variable. What is the error number variable? Where can I find that? Sock.error number. Error number. There it is. That's just an int. Okay. Anyways. Right. How do I know? Like, I thought connect is supposed to give an error if the connection was not successful. All right, let's try communicating with it. Let's do s1.send. Oh, this requires a data buffer. Send to. That's for UDP. Great. Cool. What's the description given here? There is no description. But from what I remember, send to, at least on the C# side, send to is specifically, it's for connectionless stuff. So you don't have to like establish a stream to do that. But then I also don't need to connect. And I have connected, so okay, so what is our data here? How do I create a readable buffer? Let me just look at the send method. Socket.send sends data to the socket. The socket must be connected to a remote socket. The optional flags argument has the same meaning as for receive above. It returns the number of bytes sent. Applications are responsible for checking that all the data has been sent. If only some of the data was transmitted, the application needs to attempt delivery of the remaining data. Yeah, okay, maybe I should look into the socket programming how-to guide that they created. That's probably going to help me out a lot more. Oh, you know what I could have done? Uh, shouldn't this have like a status or something like that? Connected? No. Um, Completes, you can use S for so-and-so. The same socket will read the reply and then be destroyed. That's right, destroyed. Client sockets are normally only used for one exchange. That's interesting. Okay, you know what? We are going to move on to reading this whole socket programming how-to. But first, I'm going to drink some water, take a sip of my energy drink, and then we're going to start reading. I think we are just going to be reading. Oh, all right. So a little backstory. This guide, Socket Programming How-To, I had first read this maybe 5 years ago. Yeah, maybe 5 years ago. This was a long time back when I tried to get into sockets, but I couldn't fully understand the concept of sockets. I was very new to network programming in general, but then getting into I somehow managed to wrap my head around this was like very early on. So like I had trouble, sometimes I have trouble understanding some concepts. So it took me a bit to understand it. And I was having some trouble wrapping my head around socket programming. Fortunately, I found this guide and I looked into it and I did a little bit with it, but I didn't go too far with it. Um, it did teach me. It did teach me a lot. I didn't. I don't think I ever finished it. But yeah. Anyways, we are gonna go through this again. So, this is the socket programming how-to guide on the Python website, which at this point it's probably more than a decade old. I'm not sure. I hope it's been updated over time. Anyways, abstract. Sockets are used nearly everywhere, but are one of the most severely misunderstood technologies around. Yep, that is true. This is a 10,000 foot overview of sockets. It's not really a tutorial. You'll still have work to do in in getting things operational. It doesn't cover the fine points, and there are a lot of them, but I hope it'll give you enough background to begin using them decently. That's good enough for me, dude. I'll take it from there. All right, sockets. I'm only going to talk about iNet sockets, but they account for at least 99% of the sockets in use. And I'll only talk about stream i.e. TCP sockets. Okay, you know what? That's fine with me because like it's also gonna teach me how to establish a stream along with creating the socket. Unless you really know what you're doing, in which case this how-to isn't for you. You'll get better behavior and performance from a stream socket than anything else. I will try to clear up the mystery of what a socket is, as well as some hints on how to work with blocking and non-blocking sockets. But I'll start with talking about blocking sockets. You'll need to know how they work before dealing with non-blocking sockets. Great. Part of the trouble with understanding these things is that socket can mean a number of subtly different things, depending on the context. So first, let's make a distinction between a client socket and an endpoint. No, between a client socket, an endpoint of a conversation, and a server socket, which is more like a switchboard operator. The client, the client application, your browser, for example, uses client sockets exclusively. The web server is talking. What? The web server it's talking to uses both server sockets and client sockets. Oh, okay. So the client application uses only client sockets, while the web server uses both server and client sockets. Okay, we're going to go into the history. Of the various forms of IPC, sockets are by far the most popular. On any given platform, there are likely to be other forms of IPC that are faster, but for cross-platform communication, sockets are about the only game in town. That is actually very true. That is also one of the reasons why I'm using sockets, because like I'm not only planning on communicating between two well, first of all, I'm not only planning on communicating between two programs on the same machine, but I'm also planning on communicating between two programs on two different machines, and both of those machines have different architectures. One is a Windows machine, the other is a Linux machine. So like there isn't going to be like a standard way of communicating there. Um, so sockets seems to be like the best bet. I mean, there are other options. Like to be fair, there are other options, but like sockets, from what I've seen, it's a more standard way of doing things because like sockets, they are usually when you're working with sockets, things tend to become platform agnostic. As long as the platform itself supports sockets, you can communicate because you'll be communicating in like bytes of data or maybe something a little higher level than that. But like that's all you have to worry about. You don't necessarily need to worry uh, about support. The only support you need to worry about is whether the platform supports sockets or not. So compatibility tends to not be that big of an issue. Anyways, they were invented in Berkeley as part of the BSD flavor of Unix. They spread like wildfire with the internet. With good reason, the combination of sockets with INET makes talking to arbitrary machines around the world unbelievably easy, at least compared to other schemes. Okay, so let's look into creating a socket. Roughly speaking, when you clicked on the link that brought you to this page, your browser did something like the following. Okay, so we are going to do exactly that following. So socket dot afinet, and then socket or socket dot sock stream. Great. And then there's the connect to our address. Wait, can TCP communication be? Yeah, it should be fine, right? It's my own socket, so I should be able to specify what port it's able to communicate on. Okay. When the connect completes, oh, just for reference or just for context, I'm reading the documentation on another screen, and they are currently showing some of the code. So that's what they mean by like the following. Anyways, when the connect completes, the socket S can be used to send in a request for the text of the page. The same socket will read the reply and then be destroyed. That's right, destroyed. Client sockets are normally only used for one exchange or a small set of sequential exchanges. What happens in a web server is a bit more complex. First, the web server creates a server socket. Okay, that's the server socket. Great. And then it binds. Okay, because it's a stream. Okay. I don't think you need to. I'm having a hard time remembering if a UDP server needs to bind to a socket. A TCP server needs to bind. I don't remember if a UDP server needs to bind. Anyway, so this thing binds and then it listens. Okay, so what I could do is I could, just so you guys can see some results here, maybe I could set up the client code on the other system. And oh yeah, speaking of the other system, let me set up the notebook here. Let's create a new Jupyter notebook. While that loads up, I guess we can wait. Okay, great. Let me also save this real quick. Okay, that's going to take a bit, I guess, I think. I'm not sure. All right, finally. So, NB01. There it is. Great. So I think we are good now. Oh, I need to select the, oh wait, have I not? Yeah, I've activated the thing. I need to select a kernel. It should be this one, right? Yeah, I think we're good. Let's try import socket. Great. S1 equals, oh yeah, let's import socket as sock. Okay, sock dot socket, and then we have all our usual stuff. Uh, type is stream, and that's that. Great, awesome. Let's get back. Okay, a couple of things to notice. We used socket.getHostName so that the socket would be visible to the outside world. If we used socket.bindLocalhost or socket.bind so and so, which is what they're showing is 127.0.0.1, we would still have a server socket, but it'll only be visible with the same machine. Oh, okay, that makes sense. Actually, let me test this on a separate machine before I do it here. So let's print out. It should print out the local, like it's kind of silly, but like yeah, it should print out the local. Get host by name, get host name. Yeah, it should just print out this, right? Why is the output collapsed? Okay, that's interesting. So I have the name. Is there get address, I think? Get host by address. What about get address by host? Because this just gave me the machine name. This didn't really give me... Hold on, what did that use? Yeah, it's just get host name. See, that's kind of confusing because like different machines on the same network could have the same name, right? I mean, I kind of get what it's talking about. It's saying that like you need a unique identifying number, which in this case would be the IP address. Um, but I'm trying to understand. It used it so for context, it used this get host name. But what I'm trying to get is the IP address of the machine itself. Okay, we would still have a server, but not but one that's only visible within the same machine. S.bind specifies that the socket is reachable by any address the machine happens to have. S.bind with that. Oh, okay. So it's any IP address then. Okay, you know what? Yeah, that's actually convenient because then it'll find the IP address for me. A second thing to note: low number ports are usually yeah. That's the common thing that they teach when you're doing network programming. Low number ports are usually reserved for well-known services. If you're playing around, use a nice high number, which is in 4 digits. For me, I'm currently playing around in the 9,000 range, mostly because 9,000 was what came to my mind because OSC uses 9,000. Well, VRC's OSC uses 9,000. I think in general also OSC is it the standard uses 9,000. I think so. I don't remember. The second thing to note. Oh wait, no, that's done. Finally, the argument to listen tells the socket library that we want to queue up as many as 5 connect requests. You know what I could do? I'm wondering if I could launch 2 of these cells at the same time. Like if I set up a second cell, would I still be able to um, would I be able to run both of them simultaneously? That's what I'm wondering. Because like, okay, does listen block? I have no idea if listen blocks. Because if listen blocks, um, okay. Oh shit, listen blocked. No, it didn't block. Hold up. The connection was refused. No connection could be. Oh, hold up. No connection could be made because the target machine actively refused it. Okay, so this doesn't work. What if I write localhost? Nope, still doesn't work. Oh, could it be because there's nothing listening? Okay, so let's not connect. Let's just listen. Wait, what does listen take? An invalid argument was specified. Yeah, threading is another thing that I need to look into. That's actually a whole other topic that I've been meaning to look into. Either doing bare bones threading, which I, to be honest, don't want to get into, um, or doing async stuff, which is what I'm really looking forward to because threading is great, multi-threading is great, but doing the bare bones stuff is only good if you absolutely need to do it, or if you have like a very good reason to do it, or if you're doing it for educational reasons, like if you want to learn, then it's great. But like in general, doing threading stuff, it tends to get very messy. That's why you have many platforms like they or many frameworks, they create their own system that you can use for asynchronous programming, which in the back end it uses multi-threading, but like it does a lot of the dirty work for you, a lot of the heavy lifting. It does it for you. So you're able to write more. You're able to write multi-threaded code that is less prone to errors and race conditions and stuff like that. So yeah, that's why I want to get into async programming more. I got into async programming in C sharp, and like that was interesting for me. I'm actually going to be using async programming for doing the networking stuff that I'm doing on the C sharp end, because socket methods in C sharp, they are blocking methods. At least the main methods, like the how do I say this? So you have different types of methods for each type of operation. Let's say we're talking about sending data, or let's say we're talking about connecting. Yeah, let's say we're talking about sending data. For sending data, you have, is sending a good example? No. Let's say we're talking about connecting. Connect, just the connect method, it's probably going to be a blocking method. If it's a blocking method, what that means is until the operation actually completes, it's going to block the entire thread, which is bad because if it's a regular C sharp, like a regular console uh, application, you'll be fine. Kind of, you'll be fine. Um, you just need to get something to accept the connection, or get whatever the other end is to accept the connection, or you can just crash the program itself. You can like quit the program or something. But if you're doing it within Unity, the moment the blocking thing happens, it's going to block the main thread, which means it's going to block the editor UI as well. This is assuming you're doing all this within the editor. It's going to block the editor UI as well. So basically, your entire Unity is going to freeze at that point. So you should avoid using blocking operations as much as possible. So for stuff like the various operations like connect and send and receive and all, they have asynchronous variations of them. So you can use various asynchronous programming methods that C sharp supports. C sharp has three, from what I remember. One is event based asynchronous programming. The other is asynchronous programming model, I think it was called. I don't remember. APM. And the previous one was EAP. I think with APM, or I think it was with EAP. I don't remember which one was which. You had to um, you would call a begin method, and then you had to specify an end method. And as soon as the operation completed, it would automatically call the end method, and then you would be able to do whatever extra work you wanted to do. So like it was in a way event based. As soon as that operation would complete, it would then call the thing. And the good thing was it wouldn't block the main thread. But the bad side of that was that you had to do a lot more coding, because you had to create a separate method for each of the operations you wanted to do. Um, And there were other issues as well with that. I think it also wasn't very scalable because of the way that it was set up, because you had to keep track of a lot of things. So you had to, in order to avoid things getting too complicated, you had to like make your design simpler, or you create your own framework based on EAP. And then they have TAP, task-based asynchronous programming model. Oh, ad started. Welcome back. I had no idea that the music had stopped. It's just been silent all this time. I have no idea how long it's been silent for because I wasn't paying attention to the music. I wasn't paying attention to the music at all. Anyways, so the latest one is task-based asynchronous programming, where you use tasks to actually to create the you use tasks and then there's a system in the backend that automatically queues everything up for you, and then once it's done you can just check whether it's done and then use the data after the task is done executing. That tends to be a lot more simpler programming wise. I completely forgot why I was telling you this. Oh, multi-threading. Yeah. So I want to look into multi-threading stuff even in Python, but I don't want to do bare bones multi-threading because that tends to get messy, and I would much rather do async stuff, which I'm pretty sure Python has some kind of provision for that. Anyways, the multi-processing integrates cross-platform IPC over high-level API. Wait, what is multi-processing? Multiprocessing is a package that supports spawning processes using an API similar to the threading module. The multiprocessing package offers both local and remote concurrency, effectively sidestepping the global interpreter lock by using sub-processes instead of threads. Due to this, the multiprocessing module allows the programmer to fully leverage multiple processors on a given machine. Wait, really? What? Okay, so this is something I should look into. This apparently is available out of the box, right? Import multi-processing. And is there more stuff under that? Oh, there's more stuff under that. Okay. All right, dude. Yeah, I should look into this. In multiprocessing, processes are spawned by creating a process object and then calling its start method. Okay, this is actually going to be useful for other stuff as well that I want to do. For example, like, okay, maybe I could just call CMD, right? Or would I have to specify like a full path for it? Process target F, name so and so, so and so. Oh wait, this is gonna spawn a process that'll be kept track of from within this. Is it a sub process? Okay, let's finish reading this thing. Okay, so we have now branched out. I've just started reading another module, which that's usually how my study sessions go. Anyways, the multiprocessing module also introduces APIs which do not have analogs in the threading module. A prime example of this is the pool object, which offers a convenient means of parallelizing the execution of a function across multiple input values, distributing the data across processes, which enables data parallelism. The following example demonstrates the common practice of defining such functions in a module so that child processes can successfully import that module. This basic example of data parallelism uses pool. What are... Oh, so there's also a library called concurrent. I'm finding so many extra things. Okay, so concurrent.futures.processPool executor offers a high-level interface to push tasks to a background process without blocking execution of the calling process. Compared to using the pool interface directly, the concurrent.futures API more readily allows submission of work to the underlying process pool to be separated from the waiting results. Okay, so I have some stuff to dive into here. Yeah, I have a bunch of stuff to dive into here. What about this whole class? Concurrent.futures. What is a concurrent module itself? We're looking at concurrent.futures. The concurrent package. Let's look at that. Currently there's only one module in this package. Okay, cool, great. So that's what we've been looking at. The concurrent.futures module provides a high-level interface for asynchronously executing callables. The asynchronous execution can be performed with threads using thread pool executor or separate processes using process pool executor. Both implement the same interface, which is defined by the abstract executor class. This module does not work or is not available on WebAssembly. Great, cool. Alright, so I've got like 2 or 3 of these things to look into right now. Though, okay, so for now, I think I'm gonna stop the stream because it's becoming hard to talk for me. I haven't done this in like 10 days and already my voice is now not used to talking a whole lot. I'm gonna try and stream again tomorrow. My sleeping schedule is slowly going back to what it was before, and hopefully it's gonna make it so I'm able to stream at around this time. So yeah, I'm gonna cut off today's stream here. Thanks for hanging out. I hope you guys have a nice day, and I will see you all next time. Peace. Oh, I didn't give a shout out. Shout out to Ghost Data. I've been playing their music throughout the stream. Go check them out. They're on YouTube and a bunch of other platforms. From what I understand, they also stream, so go check them out. Just look up Ghost Data on YouTube and you should find their music and their other socials as well. But yeah, I hope you guys have a nice day, and I will see you all next time. Peace.